Math 107, Final Exam Review, question number 28. Perform each of the following operations and simplify the result. All right, we're working with imaginary numbers. So in the first one, I am adding the real number portion. Negative 3 and 5 is 2. And then the imaginary portion. 4i minus 7i is negative 3i. And usually you have to put these in standard form, which means you're going to have the real number first, the imaginary number second. And both of those are part of the complex number system. For question B, we are now subtracting. So the only difference is that I have to change the signs of every thing in the group that I'm subtracting. So positive 5 and positive 9i. I'm going to stack my like terms. I now have a plus 5 and a positive 9i. So when I add them together, so I changed it to plus and I changed every sign behind it, I get a 3. 9 plus 4 is plus 13i. And again, the real number has to be first, imaginary numbers are second. When I multiply, I just multiply the real and multiply the imaginary. So that would be negative 12 and 18i. Sometimes what you're multiplying in contains an I. For this one now, I'm distributing the 4i to everything behind it, and I get 8i plus 4i squared. Now I squared, I is the square root of negative 1. So if I have two of these, the square root of negative 1 times the square root of negative 1 is negative 1. So anytime I see I squared, I need to change that to a negative 1. Multiplying those together, I get a negative 4, and I need to rearrange it to negative 4 plus 8i, because again, the real number has to be in front. Now I can FOIL numbers that can contain an imaginary portion, just like regular FOIL. All right, the first times the first would be negative 7. Outside, 7 times 4i is 28i. The inside is negative 2i. And the last, 2i times 4i is 8i squared. And I squared is negative 1. So we end up with a negative 7 and a negative 8, giving me a negative 15. 28i minus 2i is 26i. All right, I can create a perfect square trinomial if the two binomials are identical. 5 plus 2i times itself would be 25. The outside is 10i and the inside is also 10i. Then you have 4i squared. 2i times 2i is 4i squared. I squared again is negative 1. So how much number do you have? You have a negative 4 and a positive 25, giving me 25 minus 4 is 21 plus 20, letter I. Now we need to rationalize all denominators, which means we just don't want any imaginary numbers in the denominator position. It is okay to have imaginary numbers in the numerator position, but not the denominator. Well, knowing that I times I makes negative 1, that will get rid of, if we multiply the top and the bottom by I, if there's an I in the denominator spot, then we will create a negative 1 in the denominator position. So here, what I'm saying is we can multiply, it's legal to multiply the denominator and the numerator by the letter I. In the denominator, we will create 2i squared, which is the number negative 2. And in the numerator, we create, when we distribute in, 3i plus 2i squared. 2i squared is again negative 2. We need to rearrange these so that the real number is in front and divide them both separately. So we have in the numerator negative 2 plus 3i. Each of these are being divided by negative 2. I am left then with a reduced 1 minus 3i over 2. So divide them both separately. All right, for letter H, this time, when I rationalize the denominator, let me recopy that, 1 plus 4i over 4 minus 2i. When you have a sum or a difference in the denominator, you need to multiply the denominator and the numerator by the conjugate of this expression. The conjugate is an identical binomial except for the opposite sign. You're going to use plus instead of minus. So 4 plus 2i. That's going to create a difference of 2 perfect squares in the bottom. And you'll see what that produces. But whatever I do to the denominator, I have to do to the numerator. 4 plus 2i. Let me put parentheses around there. Okay, let's look at just the denominator. We would have, when you create a difference of 2 perfect squares, all you do is square the front. 4 times 4 is 16. Square the rear. 2i times 2i is 4i squared, and put a minus sign between them. That's a difference of 2 perfect squares. I squared turns into a negative 1. So we essentially have 16 minus a negative 4. 2 negatives turn into a positive, so our denominator is just 20. Now I'm going to FOIL the numerator up here and write it down here. The first times the first, 1 times 4 is 4. The outside, 1 times 2i is 2i. Inside is 16i. And the end is 8i squared. 8i squared, I squared is negative 1. So in terms of the real number, we have negative 8 and positive 4. So negative 8 and positive 4 is negative 4. The imaginary part is 18i. And these are both going to be divided by the denominator, which was 20. Make sure you reduce them each independently. The first one reduces to negative 1/5, and the second one is 9i over 10.